Hello everyone, welcome to the channel Code Liking. Guys, if you find this video helpful, please like this video, subscribe to the channel. Now let's show today's problem. Found the submatrices with the top left element and a sum less than k. So you are given a zero indexed integer matrix grid and integer k. Return the number of submatrices that contains the top left element, which means this element of the grid, and have sum less than or equal to k. For example, we have this matrix, and we need to count the number of submatrices with the top left element, so that the top left element will be included in the R matrix, and the sum of all the integers in that submatrix is less than equal to k. Let's say this example. So k is 18. So we have this submatrix have 7. So its sum is less than k, less than or equal to k. 7 6, which will be 13, is less than k. This 7 6, and then 7 6 3 16, which will be less than 18. So there are 4 submatrices. So we will output 4. So to solve this question, let's see the constraint here. M cross n is 10 to the 10 to the power 3. So we can solve this question using by pre-computing the sum of this. One question is we can check for every submatrix starting at this index also, and also we can check we can compute the sum of every submatrix which will start at this which top left corner and ending at every index. How we can calculate it? Let's say for example we're going to calculate this submatrix. So we can use the result of previous row and the same column. For example, this submatrix and the previous column and the same row, this submatrix. So we will include that into the sum. So then we will have something like this area and this rectangle. So but we have calculated, we have added the sum as this twice, so we need to subtract it once. So that's how we're gonna pre-compute the sum of every submatrix which starts at top left corner and end at the current matrix cell. So let's see the code here. We will have this vector v of size n cross m, and we will iterate over the submatrix, the matrix of n cross m. The v of ij equals to grid of ij, the current cell element in the grid, and if j minus 1 is greater than or equal to 0, we're going to include this the previous column in the same row vector's value, and if I minus 1 greater than or equal to 0, we're going to include this previous row same column vector value, and we have this taken this twice, so we're going to separate this I minus the j minus 1 value, and in the end we're going to traverse the vector v, and we will check if v of ij is less than or equal to k. We can simply return, simply increment our result and return. Time complexity will be big of m cross n, and space complexity will be big of m cross n. Guys, if you find this video helpful, please like this video, subscribe to the channel. Thank you.